Hello everyone. In today's lecture, we'll go over some of the important concepts in Numpy, and we'll first start with how to create a Numpy array, and then we'll go over in more complicated matrix analysis like multiplication of two matrices, and then how to invert a matrix, and then also how to stack two matrices horizontally and vertically, then transpose of a matrix, slicing of a row or a column from a matrix, and then also in NumPy ND array what is meant by aliasing and how it can create problem in some cases, all those things. So let's get started. We'll first type Python to get inside the Python environment. So we'll type Python here, and as you can see, I'm inside the Python environment. Next, we will import NumPy. So we'll say import NumPy as np, and suppose we want to see the version of the NumPy package that's installed in the system. So we'll say NumPy underscore underscore version underscore underscore, and it will give us the right version of the NumPy. We also have another package installed here, and that is matplotlib. We can also import that package in case we need it later. We'll see. And in order to see the package version of matplotlib, we'll type matplotlib dot version, and we'll get the version of the matplotlib package. Okay, let's now first create a matrix called mat A, which is a 3 by 3 matrix. So in order to create a matrix, we will first define the variable. So the variable name is mat A, then we invoke the numpy package, and then we call the array method. And since it's a two-dimensional array, we first create a list inside the array function, and then within that list we create 3 other sublists. So that makes this 3 by 3 numpy array. And now suppose the first row of this array has the elements 1, 0 and 5. Second row is suppose 0, 6 and 8, and the third row is suppose 2, 5 and 7. And then in order to see the matrix A or mat A, we type mat A and hit enter. We see the matrix A here. Okay, now that we have that matrix, let's suppose we want to invert that matrix. Now in order to invert that, we first need to have the inversion function, and that inversion function is already inside the numpy library's linear algebra package. So we use that. So we'll say from numpy dot lin alg, so that's basically linear algebra package, and then we import the method inv. Once we have that inv method imported, we can now invert the matrix A or mat A, and that should be it. And we get the inversion of that matrix is as shown here. Okay, Next we'll see that when we invert the matrix A, whether matrix A has changed itself or not. So we type again mat A and see that all the elements of mat A are intact. So we are good here. Next, I'll show you how to multiply a scalar with a ND array. So we already have the mat A created, which is a 3 by 3 matrix, and then suppose we want to multiply a scalar 10 with each of the elements of mat A, and then we just use this asterisk sign and then the scalar multiplier, which is 10 in our case, and we see that all the elements of mat A got multiplied with 10. Fair enough. Now our next example is how to access different elements of the matrix A. So we have, suppose, some requirement that we want the 1 element of that matrix A or mat A. For that we type mat A, and we want to, since we want the 1 element, in the square bracket we type 1 comma 1, and that gives us 6, which is the 1 element which we see here. Now, since although we have multiplied mat A with 10 here, but since we have not stored it with any other matrix, so we do not have access to that modified A matrix anywhere. So we only have access to mat A for now. So now mat A's 1 element is 6, as we can see here. Then suppose we want mat A's 1 comma 2 element, that should be 8, and we get 8 here, and that 8 matches with 1 comma 2 element here. Okay, so that's how you can access different elements of the matrix. Now when you are accessing different elements, that is okay, but sometimes we want to modify different elements which is a copy of the matrix A. By that I mean that suppose we have another matrix A, suppose mat B, which is created like mat B is equal to mat A, and then we are saying that mat B is same as mat A, and we want mat B's, suppose 0 0 element to be increased by, suppose, I don't know, maybe 5. So then if you type mat B, you see that initially mat B had its 0 0 element 1. Now in here we have modified that 0 0 element with by adding 5 to that, and we got 6 here. However, since mat B was a direct copy of mat A, it's the same matrix. So in the way I have created mat B, it has the same matrix A features. In other words, mat B is nothing but a different name of mat A right now, the way I have created mat B. So if I change any elements of mat B this way, then mat A will also change. As you can see that we have not changed anything in mat A, but mat A's 0 0 element is 6 now. Although previously when we have created mat A, we had its 0 0 element as 1. But since I have created mat B like this, whenever we change any element of mat B, mat A will also be modified. So if we do not want that mat A to be modified, then we have to create mat B. Suppose now like this. So we'll say mat B is equal to mat A dot the dot copy method, and that way if we create mat B and if we type mat B now, it's same as mat A, but it's a different version of mat A. So if I now change and again the 0 0 element, I increase the 0 0 element further by 10, and if I type mat B now, I see that mat B 0 0 element is 16 now. However, now if I type mat A 0 0 element didn't change, and this is the reason that mat B is equal to mat A dot copy now. So it's a different version of mat A. It's not the same matrix with a different name. Hopefully this is clear to you. Next, suppose get to another example of how to do element-wise matrix multiplication. By that I mean, suppose we have a matrix mat A and we have another matrix mat B, and we want matrix A's 0 0 element to be multiplied with matrix B's 0 0 element, then matrix A's 1 1 element to be multiplied with the matrix B's 1 1 element, like that. In that case, we need to use this asterisk symbol that will create another matrix, and in that matrix we'll have the element wise product of mat A and mat B. So this is just the element wise product of mat A and mat B. So as you can see that this product's first element is 96, which we got by multiplying 16 with 6. Then as you can see, it has its 0 2 element as 25, which we got by multiplying 5 and 5 here. So we got 25, like that. This kind of multiplication sometimes useful, but mostly in our application we'll be using matrix multiplication, the actual matrix multiplication, not element wise multiplication. And for that we need to use the method dot np dot mat A comma mat B. That will be actual matrix multiplication. So as you can see that this multiplication and this dot product between two matrices, they produce different results. Okay. Now sometimes we also need different slicing techniques, like we although have mat A, we want some element, some row of mat A to be extracted. Suppose that is defined by vec A now. So by using vec A, we want to create matrix. We want to get the first row of mat A. So we type mat A, then within the square bracket we type 0 and then colon. That will take the entire first row. That becomes vec A. Now if you type vec A, then we get we have made a mistake here, so it will be vec A is equal to mat A 0 comma colon. So we have to give two indices, while slicing. The first index is the row number and the second index should go here, which will be the column number. But since we want all the columns of row 0, so we put a colon here, and that gives us the required vec A here. So vec A is nothing but the first row of matrix A. And if you cannot remember mat A now, so mat A is this 605, 068, 257, and vec A is just its first row. Okay, so we got vec A. Now suppose we want to change the first element or the second element of vec A to be suppose 100, and then we type vec A to see if that number or that element has changed or not, and we see that yes, vec A's second element is 100 now. That is what we wanted, but what we did not want is that the corresponding mat A should also change. We didn't want that, but the way we have created vec A and change its element, it will also change the matrix A as well. Now when you type mat A and see its 0 1 element, we get that element also got changed to 100, and that is something we should be careful about while writing codes in Python. So make sure that you are using the copy method whenever you do not want that matrix. The parent matrix should not be modified by its child vectors that has been created out of the parent matrix. In that cases, you need to use the copy method. And how do you create vec A? Then the ideally we should create vec A like vec A is equal to mat A, then we give the row index, then we give the column index, and then we say copy, and that will create vec A like this. And now if I change vec A's first element to 150 and type vec A, we see that vec A's second element is 150 now. Okay, now type mat A, and as you can see that mat A's 0th row or the first row and the second column is unchanged, and the reason is that we have used the copy method. So these are the few places that you need to be careful about while creating a vector out of a matrix. So you always need to use the copy method. Okay, another important concept that we need to use many times, suppose how to get the transpose of a matrix. So far we have created matrix A, and then suppose we want the transpose of matrix A. So for that we type mat A dot capital T, we get the transpose of matrix A. Now is that safe, or the matrix A has been modified by its transpose now? So let's check that. So we say that matrix A is unchanged by the transpose operation, so that is safe. We do not need to have a copy of a matrix to get its transpose. Okay, now suppose in some cases we want to create a matrix with which is an identity matrix, suppose. So we'll create another matrix, suppose matrix E, because it will be suppose an identity matrix, and we create that by using the command np.I, and we give the size of that matrix. Suppose we want to create a 4 by 4 identity matrix, and then that will give us an identity matrix like this. Now suppose we need to create another matrix with all zeros, so we create mat f, suppose, or mat z, because it's a zero matrix, and we create that by saying np dot zeros, but in this case we need to give the dimension of that zero matrix as a tuple. So we give zeros methods argument as a tuple, and tuple takes the size of that zero matrix, and that creates the zero matrix for us. And we see that mat z has its elements all zeros. Okay, next, suppose now that we have a identity matrix, we have a zero matrix. Now suppose for that identity matrix we want to extract its diagonal elements, or in that matter we can extract the diagonal elements of matrix A. So for that we type np.diag, then we type mat A. That will give us all the diagonal entries of mat A, which is 6, 6 and 7. Now suppose you want to create another matrix which has which is a diagonal matrix, and the diagonal elements are same as that of the matrix A. In that case we use the diag method twice in this manner as I'm showing you here, and as you can see that this command, by calling diag twice like this, we get a diagonal matrix with its diagonal elements same as the diagonal elements of matrix A. However, matrix A is not diagonal, but output of this command is a diagonal matrix, and its diagonal entries are same as the diagonal entries of matrix A. Another important concept in Numpy array is reshaping. Now suppose we have the matrix A, which is a 3 by 3 matrix, but we want this matrix should have dimension, or it will be better for us if we consider the identity matrix. So mat E has its dimension 4 by 4. We want this matrix to be reshaped as 2 by 8 because this matrix has 16 elements. We want it to be a 2 by 8 matrix, and as you can see that reshape command basically takes a matrix and convert it to another matrix of the desired dimension. That's also useful in some cases. Another useful thing that Numpy helps us to perform is stacking two different matrices by vertical order or in horizontal direction. So let me show you what I meant by that. So far we have mat A is equal to a 3 by 3 matrix, and we also have mat B, which is also a 3 by 3 matrix. Now suppose we want to create a matrix out of mat A and mat B just by horizontally concatenating mat A and mat B. So this is the method that I'm going to show you now is equivalent to the concatenate method in MATLAB. So in Python, using Numpy package, you can have the same functionality using np.h stack method. and hStack method is nothing but the horizontal stack, and it takes input as a tuple, and the tuple should have the matrices that we want to concatenate. So we want to concatenate mat A and mat B together, and suppose we want to save that in another matrix called mat C. And if we now type mat C, we see that mat C has dimension 3 by 6, and that matrix is obtained by horizontally concatenating mat A and mat B. We can do the same thing for concatenating two matrices diagonally, concatenating two matrices vertically. Suppose the name of that matrix is mat D, and we can actually have same thing. Instead of H stack, we now have to use V stack, and mat C is now replaced by mat D, and we get two matrices. Now when you want to concatenate two matrices horizontally, make sure they have the same number of rows, and when you want to concatenate two matrices vertically, we have to make sure that the two matrices that we want to concatenate have the same number of columns. So this way we can horizontally concatenate two matrices, and mat D is now a 6 by 3 matrix. And these are the methods that Numpy offers and that I wanted to show you guys, and hopefully this is helpful. Thank you.